All right, everyone, I think it's a good time to get started. Really excited to be here with you today for a webinar about how Netflix is using CockroachDB Changefeeds and a lot more. Just want to quickly introduce myself. I'm Jordan Lewis. I'm a director of engineering here at Cockroach Labs. I like to have conversations with folks about CockroachDB. So that's another thing that I kind of do. I'm really excited to do this today. We're going to get started here in a couple of minutes. And I just wanted to start by saying that what we're going to be talking about today is how Netflix is going to be using, Netflix is using CockroachDB Changefeeds. I have here a really awesome guest named Vlad Sydorenko. He gave this talk originally that we're not going to really do a formal slides talk. It's going to be more of a casual conversation today, but he did kind of give a more formal talk about this at Cockroach Labs conference, Roachfest 2022, a few months ago. We do have a lot of videos from that conference up on YouTube. So if you do want to see some more conversations like this, some more talks about how people are using CockroachDB at interesting, exciting companies, do check out our YouTube. I think someone will paste a link to this YouTube page in the chat. So definitely do check that out. And hopefully we're going to have another conference like that at some point in the future. So if you're interested, make sure to sign up for our mailing list and all sorts of good stuff like that. Just a note on the conversation. If you do have questions or comments or things that you want to hear more about during the webinar, please drop them into the chat. I think there's either the Q&A or the chat is open for your questions, and we will try to get to them during the conversation. We're going to go for about 30 to 45 minutes, and we will try to make it through as many questions as we possibly can during that time. And lastly, before we really get started, this conversation, we do want to do more of these conversations over time. So if you do enjoy it, if you do want to hear other people's experiences using Cockroach in their data architectures, please do sign up for our webinar list. Okay, that all being said, let's go ahead and bring out our wonderful guest, Vlad Sydorenko. Vlad is a senior software engineer from Netflix, and he's been a lead developer on the CockroachDB source connector for Netflix data mesh. And that's kind of what we're going to be talking today. And so, yeah, after the call, by the way, we're going to send a blog with way more information about all this stuff that we're going to be talking about. So look out for that. And with that, Vlad, do you want to just give a quick introduction about yourself and welcome to our webinar?
Absolutely. Thanks a lot, Jordan. Hi, everybody. I am Vlad Sydorenko. I'm a senior software engineer in data movement and processing platform team. And we are working on providing, surprisingly, a platform for a universal data movement and data transformation at Netflix. Today I'm going to be talking more about the platform that we're providing, data mesh. And also specifically about the CockroachDB related part of it, I just want to make it clear, I was not the only person working on it. Some other wonderful people also contributed to it, so shout out to them. I just want to share probably some of our learnings and our experience on how do we integrate CockroachDB on scale, and how do we handle terabytes of data and integrate CDC with the rest of Netflix data infrastructure.
That's fantastic. Yeah, of course, we all work on teams, and I'm sure that there was a big, exciting team all working kind of on this stuff with you. So I guess to start off with, I thought that maybe you could help the audience understand what is data mesh and what were the kinds of problems that Netflix was running into that caused you to need to work on data mesh, you and your team.
Sure. So before I proceed with explanation, first of all, I want to make it clear that current data engineering industry has a very clear definition of data mesh. Well, actually, it's not very clear. That's why there is a lot of Google search requests of can somebody explain data mesh to me? But there is something very specific associated with it, and this is a socio-technical approach. The thing is, Netflix's data mesh is not what data mesh outside of Netflix. And think it's an unfortunate name collision. What we mean by that is that you can connect different sources to different sinks, and you can mix and match them together. That's why it's a mesh. So what is it internally? We like to say that.
Let's have an example. If you can, I interrupt you real quick. So you're saying
Yeah.
data mesh, it allows you to connect sources and sinks. Like that makes sense. We do a lot of things like that in the data world. Maybe you can give an example to help people understand what's a good reason that you would need to connect some sources and sinks via data mesh.
Absolutely. So Netflix has a vast landscape of all the tools and in general data related. Like we use CockroachDB, we use MySQL, we use Postgres, we use Cassandra, and a lot of different like internal data stores too. And the thing is, some of them are like, each one of them is good for something, right? For their specific purpose. And one of examples, for example, is imagine that you have an operational data store like CockroachDB that customers directly work with, so like it's on the critical path. But this data store has some data that you want to run analytics on. I don't know, like some machine learning models, so just to see the general health, right? The thing is, usually to run analytical queries, CockroachDB does a great job, but it's not the best place to do that. So you want to move data from operational data store into some analytical data store, like some data warehouse. We have iceberg tables at Netflix that is very widely used. Some example of that, like Redshift, Google Cloud, BigQuery, and so on. So you need something that actually moves the data. And then you're like, well, actually, I also want to search on this data. So I might want this data to put it into like Elasticsearch. Then you're like, actually, I need the same data, like from the same data store, but slightly modified, like I want to enrich it somewhere. So what data mesh allows you to do is that it allows you to define the pipeline that basically defines you extract the data once, and then you can process it in a variety of different ways. Like you can, in the same pipeline, put it into the iceberg, put it into Elasticsearch, then like do some additional processing and put it in some like third place.
That makes sense. Wait, so actually, one thing that I think about a lot is I really always love talking to you, people like you, because ultimately I work on this database. I don't get to work on data architectures as much as I would really like. So help me understand something. When you're talking about this, it reminds me of things like Airflow, for example, or systems that allow you to set up complex systems of data pipelines. Can you compare data mesh to like an Airflow or another kind of system like that?
Sure. Yeah. The thing is, data mesh started 3 years, actually probably a little bit more than 3 years ago. And at that time, by the way, very important thing, data mesh right now, it's a real-time system. So it's streaming data, basically it's built on top of Kafka, it's built on top of Flink. If we're talking about batch data movement and transformation, that's kind of a complete parallel plane. And there's a lot of like additional tooling there. So talking about streaming, this kind of part of the data processing industry is very actively evolving, and a lot of new things are being introduced. But 3 years ago, there was not much. So we built a lot of things that probably currently you can find analogs right now, like companies like Decodable, who are doing an amazing job like for stream processing, or like Debezium for CDC connectors and so on. We had to build a lot of that. But what differentiates data mesh is that first of all, it's kind of all in one, right? Usually right now, at least, I don't have a direct experience with tools like Airflow, but when I'm reading all the reference architecture, it's like, okay, get this, get like DBT, you need to mix and match all of like ton of the different tools together. And which, works perfectly for a lot of companies. Netflix has a very specific requirements, and we are fortunately in a position to be able to invest into building a platform that actually specific to our needs. Not every company needs that. So comparing, it's like, we have a connector functionality that we partially build ourselves that can be replaced with Debezium. We have an ability to define pipelines that is similar to Airflow, though we have a UI-based drag and drop interface for that. And so on. The example of the UI to define pipelines is actually in our blog post on Medium in Netflix side blog. So feel free to take a look at it. You can search Netflix data mesh, and this is probably like the first link.
Very cool. Oh, that's super helpful. I like the mental picture of kind of, we have the batch kind of job orchestration world, and then there's a sort of new world coming up, which is streaming job orchestration world. That's kind of the picture I'm starting to see in my head.
Sure.
I interrupted you before. Yeah. Mm-hmm.
Yeah, sorry, I will have to interrupt you. It's a very interesting topic. We'll be happy to chat about later, but having like completely separate stream world and completely separate batch world has its pros and cons, right? You know, you have a data governance that you need to enforce like in both places, but you need to do it differently. So right now, there is also like a lot of talk about like convergence of the platform, though if we have time, we can talk about that.
Very cool. Okay, that's exciting. Yeah, well, I'll put a note on that. I interrupted you before, though. You were starting to talk a little bit about the high level architecture, I think, of data mesh. I would love to learn a little bit more about that.
Absolutely. Yeah. So this picture looks like a lot. It is a lot. And data mesh has a lot of moving parts. I simply will not be able to go into them like in 25 minutes that we have left. Basically, I will go through like main stages. What we are doing, like what data mesh allows you to do, it allows you to basically define a connector that extracts data from somewhere and puts it into the data mesh or like a special Kafka topic. We currently have CDC connectors. You know, one of the source data stores is CockroachDB, right? And we use Changefeeds, and basically CDC connector is a separate application that translates source data store records into something that data mesh understands. We have a special serialization format that is built on top of Avro, Apache Avro. Then after the data actually makes it into that like special Kafka topic that we call source, you are able to browse through the list of sources that are available to you and start building pipelines. So it's pretty possible that you have multiple different pipelines. For example, different team has different pipelines, but they all are using the same source. Then when you're defining a pipeline, you are able, first of all, to add as many sources you want. And then you can add what we call processors. Processors are some steps that do any processing of the data, you know, transformation or like writing to another data store. This all is a processor. Very important thing is that majority of the data in data mesh is schematized. So on every step, on every hop, you can also enforce the schema. You can define which fields you need, which fields you do not, which gives us some visibility into like what's going on with the data in general. So you can have like source, processor, then from that processor, there's the stream of data that some downstream processors can consume, or you join streams of data and then you write them to a sort of data store. As you can see in this particular example, in one single pipeline, we have two sources. Every source writes to the processor that, let's say, enriches the data by calling like some third-party endpoint. Then all the streams are like merged, and then they're being written to the target data store by a sync processor. Right now, all the processors are Flink job. There's a framework called Apache Flink that is a very versatile tool for stream processing. Yeah, and also, you know, there is a whole control plane related to that, like automatic provisioning of Kafka topic. We have an amazing team who provides that provides Kafka as a service. We have an amazing team that provides Flink as a service, not just for data mesh, but kind of general from Netflix. And we are relying on all the tools available to us.
Very cool. That's a great picture. I think I'm starting to get a good sense of what's going on here. I think one thing that would also help, maybe you could give just one example of how, what's a good example of a data pipeline that you use CockroachDB with. We can start talking about that. And what does the data do? Where does it go? How does your team end up utilizing this thing in the end?
Absolutely. So one of the interesting architectures, I believe we have a blog post about it, actually, is called Studio Search. So the thing is, industry had this notion of like data product. For example, data product can comprise of the data that is scattered across like multiple tables, multiple databases, But then, you get this data together and stitch it, and then like you have something, right? So as an example, the problem was that you need to keep it fresh. And whenever one of the underlying tables is seeing a change, you somehow need to update the whole view, the whole data product. So the easy way for this would be like, whenever you need this data product, there's like an endpoint, you query all of the different like parts of it, you stitch them together, let's say by some ID, and then you return it. Sounds heavy. Especially it's hard when you need a search, right? So in this case, you simply cannot stitch all the products together. So you need to have something that actually keeps it refreshed. So let's say you have like 10 tables, like 10 CockroachDB tables. Each of them has like a different chunk of data. And then whenever one of them is updated, it triggers the CDC event. And what happens, like example of the pipeline we see is that the CDC event comes to our pipeline. Then we basically query all the other chunks to build the current state of the data product and send the complete picture downstream to update our search index. This way, we constantly keep the search index fresh. And this is only one of the architectures that we have at Netflix.
That's very cool. Okay, so let me see if I can rephrase. Every time that you get a CDC update from a change that you make to one of these CockroachDB tables, you have a Flink processor that sits around and stitches together the change event that it got with the non-changed data from other partitions of the data. Is that the idea?
Basically, yes.
Very cool. That's exciting. And then where does it end up sending the data to on the other end of the pipeline?
In this particular example, we have Elasticsearch. So that, Elasticsearch, something that immediate association.
Makes sense. That's super cool. Okay. Yeah. Thanks for sharing that. So maybe at this point, since, we could talk a little bit about CockroachDB and the CockroachDB connector that you ended up kind of leading work on. Maybe you could start by talking about how it ends up, like, were there any challenges or pitfalls that you ran into while integrating CockroachDB CDC with data mesh, or learnings that you found along the way? How did that process go of making that connector and having everything sort of fit together?
Absolutely. Yeah. So we, I am not going to give all the context about like what CDC is, what Changefeeds are, because we don't have time for that. So if somebody haven't heard of it, like, encourage you to go and read. There's a ton of articles out there. Basically, we were lucky because CockroachDB provides kind of Changefeeds that we can set up with a single SQL query. And it generates a stream of data that you can consume, and you can write to like some destinations, and then you can consume downstream. So what's been tricky about that? Like, ideally, in an ideal world, you set up a Changefeed, you send the events to the Kafka topic, and then, like, let's say that Kafka topic is a data mesh source that you can then consume. Didn't work for us. Few reasons. First of all, we have different data format. Right, and we actually started building the connector about a year ago, a little bit more. So at that time, there were no like Changefeed transformations, so we're not able, like, we had to have some entity that actually transformed the data. Plus, we have our own serialization, right? So we needed something that translates one event from one format to another. Then schema change handling. Changefeeds have their own, way to handle schema changes. But the thing for us is that whenever schema changes, we need to propagate the schema change downstream to all the consumers, like through all the pipelines. And at every step, we need to check for like compatibility of the change. And our definition of schema compatibility can be different from, let's say, the rest of the world things, or like the rest of the consumers of the CockroachDB things. So that's why we needed some place to put our logic for schema change handling ourselves. Backfill management. Also, like, pretty frequently, we need ad hoc backfills. Let's say when there is like a stream of data and it's a pipeline. It has a lot of moving parts like Kafka, Flink, Kafka, things break. So the data can get lost. And when consumers notice this, like the easiest way would be to go to the, basically re-ingest everything that is currently in the table through the pipeline again to fill the gaps. And CockroachDB, I believe does not basically the way to do that, the way to do this ad hoc backfills is to create a new backfill, new change feed that has initial scan turned on. Then force, we have pretty specific ordering requirements for the events. And the semantics that our connectors provide, across different data stores, MySQL, Postgres, Cassandra, and so on. And Changefeeds have a little bit looser guarantees. The events can be sent multiple times because whenever there's a failure occurs or something like that, it's pretty possible. We want to avoid that. So what we did, we added basically an additional step to enforce guarantees. We have state that checks the timestamp of the event and then sees if this event have previously been processed or not, so that we only emit the events once. Again, not perfect. There are some caveats, but we're doing our best to enforce this exactly once guarantee. Then data enrichment. Again, it was before the Changefeed transformations were introduced, but in our data format, for example, we need an operation that what actually happened with the row. Was it insert? Was it update? Was it delete? And we also need to mark backfills differently, backfill events. That's why we needed some entity that looks at the data and then checks what operation was that, infers this operation, and send the event downstream.
Got it. Very cool. Yeah.
Yeah. These were kind of main reasons for us to build a separate connector. Plus, we build the whole control plane. Currently, we have more than 100 connectors in prod, and it needs to be self-service so that customers can go provision all the connectors themselves with zero intervention from our side. We need some custom monitoring and so on.
Got it. Yeah, nice. That's a great picture. So there's a couple of questions from the chat. Some a little bit shorter, some a little bit longer. Let's start with a real quick one from Brad. Thanks for the question, Brad. He was wondering what are the end-to-end latency SLOs you're trying to achieve for the Elasticsearch scenario, for an example?
We are aiming at, I would say, P90 less than 5 minutes. There are no clear SLOs that we enforce, though when there's a significant delay or backup in consumer, in Kafka topics, we get alerted. So we get engaged if there are too many events or, but it's not very clear. It's just a set of expectations that we have that are not enforced.
Got it. That makes sense. And then another question related to schema changes. So I had my own question about schema changes, actually. So you mentioned that one of the schema change handling is kind of a pain. How frequent are schema changes on this kind of data at Netflix in general? And while you're answering that, I'm also wondering from Yevgeny, thanks Yevgeny, how disruptive are those schema changes to your application and to the data mesh in general?
So that's a good question. The thing is, it's all about the process of developing the pipelines. Pretty frequent pattern that we see is that a lot of databases have their test version, their production version. And so when you're setting up the pipeline, you first want to check if everything works correctly on the test data, and then set the same thing in prod. And when you're iterating, especially a lot of services, when they just start developing an application, they already want to set up some analytics or something. And whenever the application just starts development, schema changes are very frequent. We have a definition of destructive and non-destructive schema changes, and we do not support destructive. What we mean by So examples of that might be like, if you just add a column, this is a non-disruptive schema change. It's very simple. If you change the type, let's say like integer to like string, then we simply cannot accommodate that, because we need to consider the case when multiple different schema versions are in flight, because it's a Kafka topic and everything is parallelized. So we need to be able to process both. Then I'm looking at Evgeny's question. Do we tend to pause or cancel change feeds? No, we do not. Basically, what we want to bring to our customers is that they do not know what change feed is. What they do know is that there is some underlying magic that happens that allows their data to get to other place. So we want to provide this type of abstraction, and we create and manage the change feeds for them. Though there is some security concern, we don't want to directly connect to their database. We have an additional proxy that handles kind of secure operations on the CockroachDB, so that we never directly create a JDBC session and execute a SQL statement. It'll proxy.
Interesting. Yeah, I think what's such a interesting insight that I'm getting from you here is that when you're operating at scale, Netflix scale, schema changes, they really just are not isolated to the database that you're talking about, since you have such an important and large scale data architecture that you need to kind of keep in sync all at the same time. And that sounds like it presents quite a lot of challenges. So I have a couple of more questions. I want to check before I keep diving into these, if there was another point that you wanted to hit, or I think we could keep answering questions for a while if you want, or we could talk about another point.
I'm absolutely okay with that. I can talk about this for hours, but
okay.
the audience wants to know the answers. I'm happy to provide them.
Okay, sounds good. So I thought we could jump to a question from Amir, and the question is, how do you include application-specific contexts when emitting CDC events? So I think what Amir is trying to get at here is that maybe the data in the schema that is changing doesn't include enough information about the source of the data, something like this. So do you run into these kinds of problems, and how do you kind of deal with them?
So partially, when you're setting up a connector, the experience for you is that you go to our UI, you provide information about the database, the cluster you want to create connector for, the database, the table, you provide the fields that you want to include or exclude, and then you just click create. We have this metadata about the database, but we don't have information about the application that produces into the database. So if you want, let's say, some additional application-specific metadata for the table that is used by multiple applications, though, why would you do that? It doesn't sound like a good pattern. You can just, add a updated by column to your table, and then basically bake it into the data. I wouldn't say there is a good way for us to enrich the data at the very source, though downstream, you can write a processor that basically takes the data and then enriches it in any way you want, only knowing what's inside the data envelope.
Thanks. Makes sense. I want to jump to another quick topic, actually. Just since I have you here, I can't help but know if Netflix wanted to use CockroachDB CDC in more of its sources, what would CockroachDB CDC need to do? What are the next level things that you really are expecting from, CockroachDB CDC, but really any CDC? What are the next level things that we're really expecting from our sort of source databases?
So that's a great question for us. First of all, it's about stability. We see change feeds changing monthly, and with all the stability improvements and so on, though it's hard to get something perfect, right? Sometimes change feed die. Sometimes there are some random errors occurring. So we had to build our own workarounds on that. We have our own monitoring, we have workflows that periodically check all the change feeds and then apply some mitigations automatically if needed. I would say that feature-wise, we're good. Like we share a majority of our pains. Like we have a communication channel established with CR Labs, and it works great for us. Initially, we shared a lot of feedback on like what we want to see, like how we want schematized messages, being able to meet our schematized messages, and that's was implemented, and a lot of things that we needed were implemented. So right now, feature-wise, I personally do not see a lot of things that are missing, and it's all about like stability and scalability improvements.
Tell me a little bit more about, so you mentioned, you've set up some of your monitoring and observability, and that was another question from one of the attendees here. What kinds of things what do you use for monitoring and observability for CockroachDB, CDC in particular, or just CockroachDB in general?
So first of all, there are multiple aspects of this. First, the way CockroachDB is provided as a service at Netflix, we have, again, a separate team, standing team that manages all of the clusters. They have their own monitoring, they have their own alarms set up for like cluster health in general. And my team had to set up something more custom, more like, on a change feed level. And we're doing it in a very straightforward, almost dumb way. Once in like some specific period of time, we query the basically job status. Then we parse it and see, what's the current state, have the high water timestamp advanced. If it's successful or if it's like paused. Because we do not expect anybody to work with change feeds directly on the customer database, if anything changed, but we're not aware of the change, something is off. That's why we have a set of like, mitigation rules in place. Like if previous status is like running, current status is like failed, we take a look at the error message and like, is it recoverable? Is it not recoverable? If it's recoverable, like we try to restart the change feed from the high water timestamp of the previous, not restart, sorry, create a new change feed from a high water timestamp of a previous change feed so that we don't have any data loss. Though in some cases, it still requires some operator intervention because I have a slide somewhere here. If there is an edge case that you didn't clearly communicate, there will be customer with this specific use case. So if there is a way to break something, customers will always break it.
There's a law for that one, right? That's like one of those humorous laws somewhere, I think.
Exactly. I believe so. There are so many named laws. Yeah.
Got it. Yeah, thanks. Yeah, so I guess on a quick related topic, let's see, there's a couple questions here, lots of questions. By the way, you guys, we're not going to get to all of the questions in the chat. If you do still have the questions, please join the CockroachDB community Slack. We're really active there, and you can ask these questions again, and we'll actually be able to give you a more in-depth answer for the things that aren't quite, the things that we're not going to answer right now. One person is actually curious, like, about how many change feeds you generally have per table. Is it just one per table, or does data mesh kind of not notice when there's duplicates, or tell me a little bit about that?
That's a great question. Our architecture treats change feed as something that is created for one table only, and it treats change feed as something immutable. So whenever you need to change something, you do not update the change feed. You create a new one and cancel old one. It just creates an easier mental model for us, and also updates in general, like to any entity are a pain. Though there are use cases when there might be multiple change feeds running for the same table, and we have two kind of flavors of change feeds called real-time and backfill. Real-time change feed basically, as soon as CDC events gets emitted, it gets emitted through the real-time change feed. Backfill change feeds are kind of an ad hoc change feeds. Whenever we want to backfill the data, we create new backfill change feed with initial scan. And after initial scan is done, we cancel the change feed. There's been an interesting, the initial scan only change feeds were added just recently, and we're not on that version yet. So we had to build our own kind of architecture and solution that manages backfills. And we have backfill change feed with initial scan that at some point converge with real-time change feeds, and they need like duplicated data. So we have to deduplicate the data until our contour plane cancels the backfill change feed. So we have a whole flow for that.
Got it. Very interesting. Actually, on that note, and we are just about to hit that 40-minute mark, which means we do need to start winding down this conversation. It was so great. I feel like the time went like this, but I did want to ask you just on that note, since you were thinking a little earlier, we were chatting about streaming versus batch, and I feel like this is such a good segue to think about streaming versus batch. You know, you were talking about maybe finding ways to converge those streaming architectures and the batch architectures. And when I think about backfill, I think about batch in a way. And I guess I'm sort of wondering, you know, is there some sort of convergence that you see that would be a better data architecture that does some batch for the backfill and some streaming for the real time? And how is Netflix thinking about that, or you?
It is a great question. We are actually on the path of trying to incorporate batch and real-time data movement together. And that's something I'm focusing on right now. You know, that's why it's a topic near and dear to my heart. It's not a tricky, it's not an easy problem, because there are a lot of existing patterns in batch that are not portable to streaming architectures, and vice versa. So in my mind, whenever people say that like batch is obsolete and deprecated, real time is the king, it's not going to happen in the nearest like 5 years or 10 years, simply because people are used to it, right? It's very solid, like batch infrastructure, very solid and very mature. Though when we're talking about like, especially backfills, there are approaches like cup architecture, right? When the backfills are basically generated from like a different system or something like that. Like the architecture like that, we use Kafka everywhere. We use Kafka like for real time. We use Kafka for backfills. It has pros and cons. Sometimes it's hard to scale and so on. Some patterns might be, for example, all of the changes are, let's say there is like an iceberg table that has like the store of all the data, and whenever you need to have a batch process that reads from that iceberg table and sends it downstream. Though a lot of caveats, like the downstream systems are built in a specific way. They're either streaming or batch. So you convert either streaming to batch or batch to streaming. And right now, there is a lot of effort, let's say, in Flink community to create it as a framework for like batch and streaming, though initially it is solely for like built for streaming. There's Spark streaming that tries to bring streaming to Spark infrastructure. So there is a lot of interesting initiatives there, and I'm excited to see how it goes.
It does feel to me like there's some sort of like back to the past, back to the future kind of situation going on. I don't know. I remember when Lambda architecture was really hot, and Lambda architecture, it kind of went away. And now it feels like this convergent stuff is trying to bring back that in a little bit of a different flavor. So yeah, it's very cool. I mean, I'm excited to see where this stuff goes as well. So yeah, I think we are just about at time though. So I guess, do you have any last conclusions that you want to share, or any final thoughts before we kind of wrap up here?
Absolutely. Yeah, as you said, time flies. I thought we're like 10 minutes in, probably. I have a ton of other things to share. So I see a lot of questions that are not answered. Feel free to reach out to me on LinkedIn. I will be happy to share. Yeah, and so yeah, stay tuned for more updates. We are going to share what we're doing in Netflix Tech Blog, and it's exciting.
Very cool. Well, thank you so much, Vlad. I think this was a great conversation. I have to say, I haven't done one of these webinars in a little while, and this was such a good one. I feel like there's clearly a room for like a longer form kind of conversation. There's so much to talk about. Feels like we need to do these things kind of more. And I appreciate. Thanks to everyone who joined in and asked a lot of good questions in the chat and everything. As far as next steps, guys, just some people were asking about recordings. We will share out the recording of this webinar via the email that you registered with. We're also going to include a bunch of helpful resources, like things that we might have missed, or some of the links that we shared in the chat. We'll definitely reshare those via the email as well. So you will have a chance to take a look at these resources. And just as a reminder, please join that CockroachDB community Slack, because we just want all of this good conversational energy there. And it's really quite active. And I think you'll be happy if you join and join the conversation there. That all being said, I think that's kind of our time. So Vlad, again, thank you so much for joining. It's just such a wonderful way to get an insight into Netflix's data architecture and the way that Netflix is using CockroachDB. So I just really appreciate your time.
Thanks a lot for having me, Jordan. I enjoyed this conversation and looking forward to more.
All right. Well, thanks, everybody. I hope you have a great rest of your day. Take care. Until the next time. Bye-bye.
Thanks, everybody. Bye.